Mechanics is basically a branch specifically for physics, which involves, or you can say, which deals with motion, motion of anything. So mechanics is that branch which deals with motion. It can be like any motion, whatever type of motion you may think of, it should be there in mechanics, or you might learn something about it in mechanics for sure.
Okay.
In general, physics we simply see straight line motion. We do talk about motion in plane, basically two-dimensional motion, or sometimes three-dimensional motion as well. So three-dimensional motion, very rare, but yeah, in electricity, basically you learn three-dimensional motion more because there is a path which electron takes in the presence of magnetic field. So there you generally observe three-dimensional motion, and such motions are also basically helical. They follow helical path. It's quite interesting. Although to understand motion, we need few, you can say, physical things, or you can say some measuring stuff to understand that how motion is actually taking place. So there are few general things we do use. We can assume distance as one of the measuring tool, or we can even measure displacement as well. They both are different things. We can talk about speed of that object. We can talk about velocity. We can also see whether the object is speeding up or speeding down. So basically retardation and acceleration. This is also something that we may check. And at last, everything will be observed on the basis of time, because motion can only be distinguished on the basis of time. So
Okay.
with time, what changes we are observing, we need to deal with that changes with respect to time always. Whether that motion can be straight line motion, that motion can be motion in a plane, or that motion can be circular motion, rotational motion, whatever type of motion there is. Every time we are observing things with respect to time. But time, what changes we are actually observing. So in mechanics, there is a sub branch of it, and that sub branch is basically known as kinematics. Again, mechanics is a complete branch, whereas kinematics is one of its sub branches. In kinematics, we deals with motion of object without knowing its cause. Like we don't actually know why this motion is going on, why this object is moving this way. So when we are learning about motion of such objects, in which we don't worry about the cause, that sort of motion we are going to study in kinematics. So kinematics is generally a study of motion of an object without knowing the cause. Like why that motion is going on, we don't worry about it. We simply try to calculate the variables associated with the object. This is what
Okay.
the objective of today's class is. So here, let's talk about. We can assume anything. Like suppose there is a person at point A and he wants to reach at this place. Let's say. So we don't know what place it is, but yeah, we can assume that he wants to reach here. So there can be multiple ways of reaching here. If we look these 2 points with respect to Cartesian plane. If we assume these 2 points with respect to Cartesian plane, like how? Suppose a person at point A wants to reach at point B. He might have a lot of ways to reach there, but according to Cartesian plane, person's position and the destination's position geometrically is constant. So in real life, some things might not seem to be uniform, but in 3D world, we can observe that the shortest path to reach from A to B is this straight line. Like from maths, it's pretty simple, right? In
Yeah.
reality, it might be different. In reality, it might be possible that this point is surrounded near hills, and this is a place which lies above sea. Like it's above that sea. So reaching physically might not be possible, but yes, mathematically, the shortest distance between these 2 points is something we called displacement.
Yeah.
So displacement is shortest distance or path length between initial and final position. See, if we are doing class, so whatever we are doing in the class, like whatever I'm writing, try to make note of that. As much as you write, it is easier to remember these things. Otherwise, you might not be able to apply them in question if you don't
Okay.
practice them much. So that is something you should take care of. So whereas distance can be any way that person choose. Let us do a very simple, very basic question on it. If you got the essence of distance and displacement, this question will be no. This question will be very simple. Suppose there is a person and he went to a park. Park is circular in shape, like the footpath on which people walk. It is circular. The radius of the park is r. Now, person starts taking one round from point A. It reaches point B, then it reaches point C, then it came point D, and one round done. So, question is find distance and displacement for A to B path, for A to C path, for A to C position, A to D, and coming back to the same point, A to A. So, you have to find out the distance and displacement for these four scenarios or four cases. Now, think about it. Take a minute and you
So
will let me know.
the distance between A to B is 1/4 the circumference of the circle. So that's um, pi r over 2. And then the displacement would be the line connecting A and B. But I'm not trying to calculate that.
Think about it. It's a circle.
Oh, it'd be like square root 2 of r, right?
Yes, correct.
Yeah. And then the distance between A to C is pi r, and the displacement is 2r. And then A to D, that distance is um, 3 pi r over 2.
We're talking about distance.
Yeah. And then displacement again is square root 2 of r.
Correct. And what about A2A?
Oh, the distance is uh, 2 pi r and displacement is 0.
Correct. So this is how we are supposed to apply and find out distance and displacement for such a very basic and usual problem. Let me take you, let me give you another question. Just think about it. It will tell a lot about you as well. So question is pretty simple. Suppose there is a cube. This cube is some sort of, I can assume it is a sugar cube. And there is an ant at this position. This is a cube, so dimensions are A only. There is an ant at this point, and this ant wants to reach at this point of the cube.
Okay.
So you have to find out displacement, minimum displacement possible. I
Okay.
should not say minimum here. Find displacement to reach from A to B. Now again, one catch is there. This is a solid cube because I told it's a sugar
Oh,
cube you can call it.
so you can't
So
go
it's
like
solid.
that. You have to follow the edges.
You can tell me what should be the answer.
Okay.
Give me an answer. Give me a single answer.
It would be square root of 2a plus a.
Think again. Take time. Think again. Take time. And the first answer you gave is what did you
Square
give?
root square root 2 of a plus a.
Right. Now think about something else. It's not correct. All right. So that is something I leave on you. Think about it and let me know
Height
if
times
you met
width.
again. Hmm? What?
What is you wrote H and W? What does that mean?
It means you can do it at home. You can try this out later on. This is
Oh,
not a correct answer. Yeah.
okay. Wait, what's that answer then?
Think about it. It's too soon. You should easily get it. You have to think about it and see, try it out. If you do as much physics as possible, you'll automatically reach to the answer. Like it's all about visualization. Just think about it. From A to B, what should be the shortest path? Think of a cube.
But you can't go directly through the cube, right? You have to
Yeah, we
go
can't
down.
go. Yeah, that's true. We can't go directly. So still, it's not correct. Think about it. Let's take it right. Uh, so this is the displacement of one thing, and you got the essence. You know what is distance now. What is polar displacement? In order to measure that how fast a particle moved from point one to another point, we need to measure the speed. So here comes the another variable which is called speed. So speed is basically rate of change of distance. Now this is quite important or unique definition you can say. Speed is rate of change of distance. You have heard rate word in calculus.
Yeah, derivative.
Yeah, so it is exactly dx over dt. Like how rate is changing. Or I should not write it in this way because it should be specifically written for velocity. Whereas we do talk about how position is changing with respect to time. This is how we generally understand this. So let us start with a very basic illustration and then we move towards something interesting. So suppose there is a particle at point A. It went to point B covering let's say 20 kilometers with 60 kilometers per hour of speed. Now you might feel that the scale I'm using is different. Or let me take a familiar one. So you can assume that a particle is moving from point A to B covering 20 miles at 60 mile per hour speed. Similarly, from B to C, the same particle covers 40 miles with 40 mile per hour speed. So the question is, we have to find average speed. And in this case, as the particle is moving in straight direction, straight line, so average speed and average velocity is going to be same.
Yeah.
So how can we find it out?
Um, but see how much time it takes.
All right, no, let's see this. So always understand that if we have to calculate speed, we need two things. We need first that how much distance that object has covered and in what time it has covered. So if we calculate this, we get speed. But in order to calculate average speed, we simply take summation of the distances. So we can say this, it should be total distance per unit total time. In whatever time the whole distance took place, division of this will give us average speed. So here, total distance is going to be what? 20 miles plus 40 miles. So 20 plus 40. But what about total time? We should have time to find average speed. So how can we find time using this data? Just think about it. You have to cover 20 miles and you are, you
So
can say,
the
riding at
first
60
thing
miles
it
per hour.
would take
So how much time
20
will it take?
minutes.
20 minutes, right? And in second case, from B to
Um,
C,
1 hour, right?
right?
Or 60 minutes.
So here, if you have to write it in minutes, you can write it in hours as well. So it is 1 by third. The total 4 by 3 hours it took. You can solve it and we'll have 15 times 3, that is 45 miles per hour. This is the speed. Are you getting it? It's not 50. Generally, what student do is 60 plus 40 by 2. That is 50. And fun fact is 50 is there in the options, which we generally choose, like for the same question. Because options were not only prepared randomly, they were also prepared in such a way that if a student does something wrong and he reaches to the conclusion should be there in the options.
Yeah.
So that is the reason why we might feel that we got it, but it wasn't that way. All right, so this is what average speed is. This is what velocity is. Let's make it a little interesting. Let us try to solve it in terms of variables. Because whenever we are doing calculus, we simply use a lot of variables here. A very basic question, but think think well before answering it. You need some to solve it. So assume a particle travels from point A to B and then from B to C. From A to B, it traveled at speed v1. From B to C, it traveled at speed v2. Or the question says a particle covers half of the distance with speed v1 and another half of distance with speed v2. You have to find that what is the average speed. You're not going
Okay.
to use uh, anything difficult here. If you think properly, the way you think in the previous question, you can reach to the answer. See, whenever we are solving any question in physics, we always have to start from the very first, the basic one, the first formula, or you can say the equation we saw related to that topic. So for average speed, I simply told you it should be total distance by total time. So we always have to start from that relation only.
Okay.
Obviously, we are going to manipulate equation and substituting the values, but before manipulating those equations, we need to write that equation. So average speed is nothing but total distance over total time. What is the total distance? We don't know. What is the total time? We don't even know this. Can we reach there? Let's try. So
Okay.
from A to B, question says something. Let's read it. A particle cover half of the distance. Half of the distance means total distance and half of it. So I can assume that the total distance was x. Half of that distance is x by 2. So this is going to be another x by 2. Think about it. If a particle covers this x by 2 distance with v1 and similar distance with v2, will it going to have different time to cover the same? Will the same particle take different time to cover the same distance or the same time?
Wait, can you say that again?
Yeah, let me say it again. So the question is, if a particle travels from point A to B and B to C, which is equidistance, so
Yeah.
will particle take different time or same time to travel from A to B and B to C with speed v1 and v2 respectively?
It would be the same time, right?
No, you didn't get it. You didn't get what I'm saying.
Oh,
Let's look at it again. So basically, the question says particle covers half the distance with speed v1, another half with speed v2. So my question is, will it take same time to do so or the different?
oh, different because the speeds are different.
Exactly. So here, let's assume that for this A to B, it took t1 time, and from B to C, it took t2 time. We can assume that, and we can simply substitute it. Let's see what we get. So here, the total distance is going to be x by 2 plus x by 2. The total time is going to be t1 plus t2. What can we substitute for t1? Think about it. Speed is distance upon time. Speed during that time is v1. Distance is x by 2. Time is t1. So what is t1 going to be? X by 2 v1.
Yeah.
So average speed is going to be x over x by 2v1 plus. Similarly, if you're going to find out t2, we'll reach
X
the same
into
conclusion. Yeah, you can simply solve this equation, take out whatever feels like common. The average speed in this case is going to be 2v1 v2 over v1 plus v2. So just look at the topic. Like we are talking about speed, but still it can be made very complicated. There are a lot of form questions that we should look at once because see mechanics this is like not everybody's game. You need to be very much strict with the schedule as it if there is something you have to work upon is the practice. You have to practice a lot. If you are practicing, then only you'll be able to somehow make it to the finals well, because the variations are a lot, there are a lot of variations,
okay.
the topics are so huge, and you need to work more. Again, consistency is the key. If you are consistent, then you can make it. That's all. So let's think of something else now. So this is so first we learned about distance, then we talk about displacement, then speed and velocity. Let me give you a little bit example of velocity. Talked about speed. Now let's talk about velocity. So velocity at first is a vector quantity. In maths, you might learn vectors, I guess. Have you?
Yeah, yeah.
So the same vectors are here. Like basically the math in maths, you're learning the mathematical aspect of vectors. But in physics we apply it. We apply those things, we use those things to represent the directions of different physical quantity with which we deal. So it is one of those quantities, it is a vector quantity. Like if I give you an example, suppose there's a point A and point B. There's a person riding a bicycle at 40 meters per second of speed. So someone sees it, they call that speed is 40 meters per second. But if we have to say about its velocity, we'll say 40 meters per second from A to B. We
Okay.
have to specify this direction, and that direction is a characteristic of vector. So you have learned vectors in maths. In maths also, we do get to know this part that where we are actually going to apply this particular part of we can say subject in real world. So just think about it and tell me what are the practical applications of vector.
Um, these are to denote forces, right?
Just could denote forces.
Yeah,
Think about
like
no, think about something practical, which we might use daily, which we might see daily, which we use daily, something like that. What is the practical application of vector? Without vectors, that thing was not possible. And trust me, you use it daily.
AI.
Hmm?
AI.
No, not really.
Um, I don't know.
See, vectors have a lot of applications, but one of the most fundamental and the important one for me is navigation. Navigation is one of the most, we can say, best discovery because without vectors, without knowledge of vectors, navigation is not possible. If you ever share your, we can say, location, you'll find that you are actually sharing the coordinates. What are
Yeah,
those coordinates? Those coordinates are the position of you on this earth, and that position is going to be very specific. Like, have you ever wondered that the location of a particular place, person is very specific? No two such positions are possible. How is it possible? Like, how it is so specific?
yeah.
Like, do you think about it? How is it so specific?
The location of a person?
Yeah, why they are so precise?
No, not really.
You might had, I guess. So every point on Earth basically lies in one of the eight quadrants. Generally, we deals with two quadrants in maths, but in real world, navigation is done using considering the third, the another half of the sphere as well. So there are total eight quadrants in which Earth can be divided, and every point has two things very specific. One is coordinate, and another is angle. Angle made by that point with given plane can be horizontal or it can be vertical. So this is something which makes location to be so precise. Like we used to locate these two things, and locating these two things were only possible because of knowledge of vectors. So if we don't have vectors, today we won't be using that navigation part in our real life because in everyday life we use navigation a lot. So that
Yeah.
is the thing. That is the key thing. Again, everything you are going to learn in physics, it has a lot of practical sense. Nothing here you are learning for giving some knowledge to others. This is something which is real world. This is nature. Although there are some things which we don't even know, and we are learning that why is it this way. We don't have that idea that why is it this way, but what we know is that it works. So if I want to write more about vectors, I simply say vectors are those physical quantities where algebra won't work. Specifically, for example, suppose there's a particle, it lies here with respect to certain position, with respect to some origin, the particle might be at a certain coordinate. Let me write it as x, y, z. So if I want to write the position, or if I want to represent the position of the particle with some position vector, we'll be using two points in space. The first position of that particle and the second origin. With what respect I am calculating the position. Like in physics, every time we see something, we observe that it must be there because of someone's point of view. Every time you are referring to something, you are referring with respect to something or respect to someone. Here
Yeah.
also in physics, we are going to represent position, speed, acceleration, or any fundamental variable which we are going to calculate with respect to something. And that with respect to something, in most of the cases, is origin. Or you can say it's a imaginary position, obviously, because in space you can't define it. For Earth, if you just see the origin is this. So for all the navigations and everything, we assume this origin as the center. That's why every point has a unique position and angle it makes with the origin. Because origin is one only for Earth. So we need those two things again. So we have to write the position vector. Let me assume these 2 points as O and P. So position vector OP is represented by capital letters where at the top there is arrowhead, and this is simply given by the difference in coordinates representing their direction in each axis. What do I mean here is that this OP vector, this displacement vector, will be equals to xi cap plus yj cap plus zk cap. It means that the particle is going exactly, let's think about it, what it says. It has exactly gone x distance in x on horizontal axis. It has gone y distance in vertical axis, and we can say in y plane, and z distance in vertical plane. So as a result, it reaches at some point, and that is this point. So this x, y, z are basically representing the coefficient of that particular vector in this given axis or in this given direction. You can assume this I, j, k are basically the directions, or we also call them I, j, and k. We call them direction cosines. Call them direction cosines.
Okay.
Yes, we can write them in terms of cosines. So vector is something which is representing the position of a point. Vector is something which is representing that how far a point is from origin. In that case, there must be some origin, we don't know. But yes, there must be some origin because every time we are writing a vector, we are writing it with respect to some origin. So there are a lot of vectors. There are position vector, there is a displacement vector, there is a speed, velocity. So let me just give you a few examples that how you uses vector along with direction. So let me take you to the examples. I'm assuming that there is a plane. This is the vertical axis. So in this plane, there are few things. There is one road going this way. There is another road coming this way. There is one unexpected 90-degree flyover this way. And you can also expect something here. So just imagine I have drawn some random paths. There is a bicycle going in this direction, like that. So as the particle is moving in x-axis, so I can simply say that velocity might be 2 I cap. I cap is representing that the motion is going on in horizontal axis, x-axis. And maybe it is moving with 2 meters per second, so I write 2 I cap.
Yeah.
Similarly, it is possible that some car is going on in this direction. So as the particle is going on in y, you can simply assume that velocity of that car is let's say 5 j cap, where j is represented by the y axis, I is represented by the x axis. Similarly, you can simply assume that someone is flying or going up this plane, up this xy plane. So it is going in z axis. If it is going in z axis, so we can assume that particle must be, let's say, moving with 10 meters per second here. So the velocity is going to be 10 k cap. Velocity is going to be what? 10 k cap. Now, simply imagine that some particle was at this origin and it is going in all the planes all together, in all the axes all together this way. What can I say here? In that case, the vector must be, in that case, the vector must be going in all the axes all together. So it will have some x component, it will have some z component, it will have some y component as well. In that case, the equation for such vectors are, you can say, given by x 2 I cap plus 3 j cap plus 4 k cap. So if you see a vector which has all the direction cosines into it, it means the particle is moving in all the three directions simultaneously. Now, let me try to make you understand it more. Because vectors is no joke. You have done this in maths, it would be great. Only if you can apply it here. So as of now, let me just take that particle is moving in this plane and in this plane. This is some plane. Let me assume xy plane. Particle is going like that with, let's say, 10 meters per second of velocity. So velocity must have here two components, x and y. And how can we find out x and y component? That is the question. In order to find out this x and y component, we need some angle. We need the angle made by the vector with either this axis or this axis. It can be x, it can be y. Suppose this is the angle between this vector and x-axis is theta. So the question to you is, how can you find Vx and Vy? Vx is a component of velocity in x-axis and Vy is a component of velocity in y-axis. Just think about it and tell me, what should be Vx and Vy?
Vx should point in the x. Oh wait, it'll be like 10. What degree is theta? Like, what is the
Mm,
value of theta?
yeah, okay, let us try to understand. So basically I said that there is a particle. It is going with 10 meters per second of velocity in xy plane, the way I
Yeah,
have shown it here.
yeah.
And it also says that the angle made by the particle while going into this xy plane is theta. Let's say it is given. So
So
velocity must have two components.
yeah.
Something will be there in x-axis, that's why particle is able to proceed in x-axis, and something there is in y-axis as well. That's why particle is going away from x. So what are those components? How can we find out those components? That is
It's like
something we call vector resolution.
10 cosine theta and 10 sine theta, right? Or is it different?
Yeah, 10 cosine theta and 10 sine theta. How you got it?
Uh, because you can find the components of a vector by looking at the magnitude and the angle that it makes in the xy plane. So in this case, the magnitude would be 10, and the angle is theta. So 10 cosine theta, 10 sine theta.
Correct. Or there is nothing like that. It is calculated that way. Just think of it. This side is representing 10. This side is representing theta. This side is representing Vx. So which trigonometric function should I use so that I can incorporate this base
Cosine. So cosine of
and
theta equals Vx over 10. So Vx equals 10 cosine theta.
exactly. This is how we got it. Similarly, we can have Vy as 10 sine theta. So here I can simply write that Vx is going to be 10 cos theta and Vy is 10 sine theta. So what is this V going to be? So V must be 10 cos theta I cap plus 10 sine theta j cap. So this is the actual velocity vector for this particular object moving in this direction.
Yeah,
Got it?
yeah,
So yes, I guess I gave you enough overview of this thing, that what is the level of questions, or what are the things that you're going to deal with here. Again, vectors are the backbone of physics. Those who are good in vectors, those who are good in maths, they does really well in AP mechanics. So you also have to think in that way. You also try out doing things in such a way that you can connect the real world, because everything we are going to deal here, it is there in the real world. So if you are able to establish the connection, these things becomes so easy. You just have to visualize them. Those who visualize better in physics, they automatically performs well. So I guess let's keep it till here only.